Hey physics. So this is activity 2, which is titled, Does 5 plus 5 always equal 10? So this is to deepen our investigation into whether the continuous model of matter fits best or the particle model of matter fits best. We're going to look at some liquids and we're going to combine them and we're going to see if they do what we think they would do. So first thing we did here is I took actually it was 10 milliliters of water plus 10 milliliters of water, and that added up to 20 milliliters of water, just like we thought. So 5 plus 5 ended up being 10 parts of water. We did the same with ethanol. 5 parts of ethanol plus 5 parts of ethanol also added up to 10 parts of ethanol, just like we would expect. But then we poured equal amounts of ethanol and water, so 10 milliliters of water plus 10 milliliters of ethanol, and it added up to about 18 milliliters. I just wanted to show you what that looked like on the table here. So 10 plus 10, 20, and that's what it turned out to be. 10 plus 10, we'd think it'd be 20. It turned out to be 20. This is where it gets interesting. We had 10 milliliters of water and 10 milliliters of ethanol. We thought it ended up being 20, and it actually ended up being 18 milliliters. Now the reason that this is happening is that the particles, we can explain it if we think about it with the particle model of matter. Because the particle model of matter says that when you break things down into smaller parts, they can be different sizes, right? If we're dividing everything equally in half over and over and over, it's going to be the same size. It's going to be like based on like how we divided it, and not like, so it couldn't be bigger and smaller. When we're looking at a liquid, it doesn't make sense if it's continuous for them to add up differently, because everything would be the same size, so why would it add up to be different, right? So the idea here that I want you to remember is this idea of a jar full of rocks and sand. If you put those rocks in first, then the sand is going to trickle all around in it. Ethanol molecules are a lot bigger than water molecules. So the water molecules, which are a simple kind of V-shaped structure, I'll show you what those look like in just a second, they can filter in between the ethanol molecules, and it's like a more efficient use of space, basically. So it's not going to end up to a full 20 milliliters there. Okay, so let me show you an ethanol molecule and a water molecule coming right up. So this is a water molecule. It's just one atom of oxygen and 2 atoms of hydrogen. So then this is actually an ethanol molecule. It's got 1 molecule of oxygen, 2 molecules of carbon, and 5 molecules, actually it's really 6 molecules of hydrogen. Okay, this is called an OH compound there. So there you go. That's what this one is about. They filter together like marbles, or like rocks and sand. Okay? I said I want to be more precise with my words there. They don't filter between. They fit the smaller water molecules, or smaller water particles is another way to say that, fit in between the larger ethanol particles. Okay? There you go.